All right, so today we'll finish our conversation on partial fraction decomposition. So this is section 7.3, and we'll be finishing partial fraction decomposition. And what we'll talk about today is every example we've seen so far, the top power, the numerator power, has always been smaller than the denominator. This is the notation we used, if you remember, going back to rational functions, when we were graphing rational functions. The top degree, or the numerator degree, was always smaller than the bottom, or the denominator degree. Today what we'll be doing is we'll be looking to see what happens if the top power is greater than or equal to the denominator. All right, so what we're going to have to do is, if the top power is greater than or equal to the bottom power, we have power. What we do is we do long division. And then the remainder we actually do the partial fraction decomposition on. So I only have a couple examples today. Let me show you what this looks like. Say if we had 2x to the third minus 4x squared minus 15x plus 5 divided by x squared minus 2x minus 8. Well, we should factor the bottom. This will just be x. Actually, before we even start factoring, I mean, it doesn't really matter what it factors to. You see how this top power of 3 is bigger than this bottom power of 2? That means we have to do long division first and get the whole part. And then the remainder is going to be over the factors. All right, so let me show you what this looks like. Because this top power is greater than the bottom, we do long division. So with long division, we're going to divide x squared minus 2x minus 8 into 2x to the third minus 4x squared minus 15x plus 5. So x squared, we could put 2x here. We'll get 2x to the third minus 4x squared minus 16x. We'll change the signs. Remember, we always subtract at this stage. And we'll get no x squared, but we will get just an x plus 5. All right? So the way this is going to work is we always write the whole part plus the remainder over the divisor. So our answer is going to have 2x in it, the whole part, but we have to decompose the remainder part. And that'll be pretty easy. It's not as involved as yesterday. So let me show you what that looks like. So the remainder is x plus 5 over x minus 4 times x plus 2. And we'll break that up like we know how to do. We'll write x minus 4, we'll write x plus 2. I have a and b here. The LCD is x minus 4 times x plus 2. So we get x plus 5 is equal to a times x plus 2 plus b times x minus 4. Now we talked about a few different ways to solve this. I mean, it doesn't matter which way you do it. You could pick different values for x. the way we did problems yesterday. Once you get more advanced, you make systems. So we could always do systems. I mean, you could set the x equals to numbers if you have linear factors like we have here, x plus 2 and x minus 4. So that just might be a little bit easier for me, so I'm going to do that. I'm going to let x be negative 2 because that'll make this 0, and I'm going to let x be 4. That'll make this factor equal 0. If you don't remember me talking about this, go back to part 1 of partial fraction decomposition. So this will be negative 2 plus 5 is equal to b times negative 6. So this will be 3 is equal to negative 6b, and b would be negative 1/2. If we were to plug in 4, we would get 4 plus 5 is equal to a times 4 plus 2 is 6. So that would be 9. And we would get that a is equal to 3/2. So as far as what our answer would be, what you would do is you would write the whole part that came from division. So if we scroll back up, the whole part was 2x. Plus, you write the decomposed remainder. All right, so we had a over x minus 4 plus b over x plus 2. And a was 3/2, and b was negative 1/2. That's a little bit funny to write a fraction over a fraction. So 3/2 divided by x minus 4 is the same thing as 3 over 2 times 1 over x minus 4. I mean, it'd just be a little bit better if we wrote it like this. And that would be the right answer. So we have, maybe one extra step, but I think yesterday's lesson might have been a little bit harder. We'll do one more example. What if we had a problem like this? X to the third minus x plus 3 divided by x squared plus x minus 2. I see the top power is greater than or equal to the bottom. So we'll do long division. Remember, we always put 0 in if we're missing a factor, or if we're missing a term, I should say. And using long division, we get x Remember, we have to subtract these. X squared times negative 1 is negative x squared. Subtract these. And we'll get 2x. 3 minus 2 is 1. And we can't divide anymore, so that becomes our remainder over the divisor. Now this is the whole part. We're going to use that in our answer, but we have to decompose the remainder. So let's go ahead and do that. It's going to be x plus 2 times x minus 1. We'll get 2x plus 1 is equal to a times x minus 1 plus b times x plus 2. So again, we could either make a system or pick different values for x. I'll pick different values of x. That's preferred for me. So if x is 1, we'll have 2 times 1 plus 1 is equal to b times 1 plus 2. And if we plug in negative 2, we'll get 2 times negative 2 plus 1 is equal to a times negative 2 minus 1. And then that's going to be 0. So we'll get negative 4 plus 1 is negative 3 equals negative 3a. So a would be 1. So as far as our answer, x to the third minus x plus 3 over x squared plus x minus 2 is equal to the whole part we found was x minus 1. And then we're going to do the decomposed fraction, or decomposed remainder. That would be the answer. All right. So for homework, what I'm going to ask you to do on the worksheet, I would like you to please do, let's say, numbers 3 and 4, and numbers 8 and 9. Thank you very much. Have a nice day.